Hi folks, this is the second video for week one. This is going to be a basic Python review. That's what it's called anyway. I think there are some new things in here though. For those of you who have taken Python before, there's a couple of key features that I'm going to highlight here that you may not have seen before or may not have thought that much about before. So I'm going to highlight the basics and then just quickly go over those few key things. So I want to point out the materials here. I'm going to go over some parts of the Python and NumPy notes. The readings kind of point you to different places for what you need to read for this week. We're not going to use any of the example code this week. I'm going to make a new example in front of you and I'll probably post it afterwards. So by the time you're watching this, it'll probably be here. And then I'm going to leave you guys with a couple of exercises to try. I think with just one exercise from this video, just to get your feet wet, and then there'll be more exercises for the lists and dictionaries and sets one, which comes next. As I talked about in the learning plan, the software is available here. I'm recommending Anaconda Python and the Paizo IDE, but you can use whatever you want, as long as you have the capability to install the packages, NumPy, Matplotlib, and sklearn. There's a couple of other resources here. W3 Schools has pretty good Python tutorials which you can take a look at. Those are for quick access to sort of key facts. There's also this textbook here called Think Python, which might be useful as well. I have that up over here. It doesn't look very impressive, but it's a pretty good little book. It's written for as an introduction to programming. But it's very tight and concise, and so it's you can see the chapters here: variables, functions, conditionals and recursion, etc. This is return values, loops, and so on. It's a good place to dip into to get the basic Python syntax. If you take a look at the readings for this week, you'll see that we're covering these three things this week. The fourth topic is for next week, which will prepare you for part A of assignment 1. I'm suggesting these chapters from Think Python, or you could use W3 Schools, as you need to. And then these chapters plus the handouts and maybe W3 Schools, again, as needed for Python lists and dictionaries and sets. Okay, let me start up Paizo here. So if everything's been installed correctly for you, and if you're going with my recommendations, then when you run Paizo, it should automatically show you Python 3.8.3 here. If it doesn't show you that one, if you have other editions of Python on your system, you can edit it there and then go in here and choose the one that you want. Okay, so I'll leave that with you guys. Another option, if you really can't get it configured the way you want, is to get rid of the other Pythons and then reinstall Anaconda and reinstall Paizo and come back in. If you've only got Anaconda and Paizo, then it should automatically boot up. So what we're looking at here is this is a code window. This is an code editor window. This here is the Python shell. And when you first run Paizo, you're going to see different selections down here. If you go under, I think it's Tools, you can get the interactive help window up. You can also, you should be able to, there we go, you can rearrange them so you can put windows next to each other and so on. I think what you get is maybe the file browser. I forget. You get two different things down here. I usually get rid of all of them and just leave the workspace there, which I'll show you how to use in a moment. That's I think the most useful one. And if you want to, if you see Python 3.8.3 here, that's good. If you want to make sure that everything is installed properly, just in the shell type import numpy like that, and it'll take a minute, and then it should come back having loaded the module. That means you're accessing Anaconda and you've got numpy in there, and everything is good. And you'll notice when you do that, that the numpy appears in the workspace down here. And the reason for that is because the workspace tracks all the current names in the space. So let's create a variable, which you do in Python just by typing an assignment, a equals 5, and you can see, I don't know how well you can view this, but I don't think I'm able to increase the font down here. but a is an integer, and its value is 5. You know, here we go. B is a string now, with the value hello. Okay, so this is the shell here is like a little sandbox that lets you play around with stuff. You can try, you know, you can just do expressions here. You can treat it like a calculator. A times 5, a plus b. It's going to be a syntax error, a type error, and so on, because we're trying to add a string to a number. So you can try out syntax here before you put it into your program that you're building over here. Okay, so I use the shell a lot, and we'll use the shell a lot for in-class demonstrations and so on when we're getting going. All right, the other thing to note is that if you don't already know this, there's a big difference between Python 3 and Python 2. Python made a very kind of brave and bold decision to replace Python 2 with Python 3 and make it not backwards compatible. So Python 3 is not the same as Python 2. The easiest way to tell the difference is that the print statement in Python 3, the print is a function. So if you just type print and hit enter, it's going to tell you it's a built-in function. In the older versions, print was a special statement with its own syntax. So if you're looking online for examples of code and you see print statements like this, that means you're looking at Python 2. There are some other subtle differences as well that can mess up your code. It's not just about the print statement, just something to be aware of if you're going online and getting help, that make sure that you're looking at Python 3 code or that you know how to convert it. Another big difference is in division. If I go 5 divided by 3 here, it even though these are both ints, I get a floating point result. In the original Python 2 was more like what's common in languages like Java, which is it would not convert that and it would just answer 1. So it would if you give it 2 integer operands, it would come back with an integer result. Python 3 has replaced that with the double slash, which means they refer to it as floor division, meaning you do the division and then you take the floor, which means you round down. So if you need to do that kind of division, it's the double slash there. And there's a bunch of other subtle differences as well, but those are maybe the 2 big ones that could potentially really mess you up if you are trying to go from Python 2 to Python 3. So 2 things to know about. Okay, so Python, just a little review here about types. Python's dynamically typed. That means you don't declare variables. A variable can take a value of any type. There are types in the language, but values have types, variables do not. And here are some of the important types: int, float, str for string, bool, list and dict, and there's also set, which we will look at. We'll look at those 3 things in a future video. If you want to know what type something is, you can use the type function, and if you want to convert, you can use each of these names as a function, essentially as a constructor, to create a new value of that type. So down here I can go type A, and it will tell me it's an integer. Type B is a string. Type true is going to be an error, because booleans in Python have to start with capital letters. So it's capital T true, capital F false. So that's how you find out the type of something. It's going to tell you it that way. And you can also convert. So if I decide I want A, which is currently an integer, to be a floating point number, it's like this: float A returns a float. So I can go A equals float A, and now A is a float. Okay. You can also do stuff like this. You can go int. If I go int B, it's going to give me an error because B is the string hello, which can't be converted to an integer. But if I give it a string that can be converted, it will go ahead and convert it for me. Okay, so that's how you do your type conversions. Some of them will work, some of them will not. Errors like this can be caught. There is a try-catch statement in Python that you can catch errors with as well. Okay, the basic syntax. There's no semicolons. Code blocks are indented after a colon, not a semicolon, but a colon. We use and or not instead of these operators from Java-like languages, C-like languages, and we use hashtag for a comment. Paizo also supports the double hashtag. So let's take a look at that. Let me do a I'm going to save this. So save as. I'm going to put it in machine learning, week 1, 2, in class examples, week 1 basic syntax. Just call it that. So now I have a file called that. I'm going to, let's do just a equals 5, oops, no semicolon, if a is less than 3. Sorry, my Java is showing here. No, you don't need to have the brackets there. If a is less than 3, and then you could do something like print success. So there's a very simple little program. Let's say if a is less than 10. Now, how do I run it? I go over here. You can see that there's a bunch of ways to run. I think the best thing to do here is just Control-Shift-E, run file as script. What that does is it reboots the shell over here and runs the code here in a new clean shell. There's other ways to do it, like you can say execute file, Control-E, but it won't reboot the shell. So if I go execute file, it says success, and notice that I still have B and NumPy defined in my workspace. So that's it. You should be careful doing that. Don't just execute file, because it can hide errors. So when I go to run your program, if you create a program in one session and you have some variables in your workspace, execute file allows this file to make use of those variables that are in your workspace. So I can go print B like that. I go execute file, and it says hello. Everything seems to be working, but when I come in with my brand new shell, so I can restart the shell here and then try to run your program, oops, it doesn't work anymore because it was using something that you had in your workspace that I don't have in mine. So the solution for that is to always use run file as script, the first option here, which is Control-Shift-E. You have to have the file saved first before that will work. So it might fail the first time if you haven't already given it a file name and saved it somewhere. But run file as script, you'll see it reboots the kernel and then it runs the program. And there's the beginning of my output right there. Okay, so you can have multiple statements in a block like that, and you can put an else like this. And if we make a equal to 50 here, I'm going to now start using Control-Shift-E, so you won't see me selecting. Now it says fail. If I say 5, Control-Shift-E, it says success FDSA. So the indenting level is important. The only real way you're ever going to see a syntax error in Python is if you do something like this. So this is a syntax error. It won't even run. It's telling me that there's an indentation error there. It's one of the few syntax errors you're going to see in running Python. Okay, so that's basically how things look. The if statements, you have an if statement and you have a while loop, but I may be getting ahead of myself here. Oh yeah, let me show you a couple more special operators in case you didn't already know about them. These are kind of cool. Whoops. So down here, if I go 2 times 5, that's 10. If I go 2 asterisk asterisk 5, that is 2 to the power of 5, which is 32. 5 to the power of 2, which is 25. And of course, if you do something like this, 2 to the power of 10,000, that will overflow most languages' integers, but not Python. Python has, by default, has big integers. So the integers can grow as big as you want them to. So that is 2 to the power of 10,000. That's what number it is. So that's good to know as well. And it's good to know when you're converting between languages, because other languages won't be as forgiving about their integers. Concatenation is plus, like that. You can use either double or single quotes. I accidentally hit the single quote there, but I just went with it. And here's something kind of cool. Most index types, like strings, you can multiply them. So if I go high times 5, I get that. So x equals high times 50 gets me x containing a string with the word high repeated 50 times. That also works with lists and stuff like that as well, which we'll show in a future video. You can create a quick list by using the multiplication operator. So that's kind of cool. Okay, input and output. We've got the print statement. We've got input, which just gets a raw string. This is something that's different from Python 2 as well. Python 2 had a function called raw input, but in Python it's just input. So if I go x equals input, and then I type something here, x now has the string that I typed. If I wanted to get an integer from the user, I would do something like this. X equals int input, and now x is not a string, it's of type integer. Type int. So I'm using the conversion function here to convert the string that's coming from the input statement into the type that I want. Of course, you're going to open yourself up to errors when you do that. So that fails because it can't do the conversion and it will crash the program. But for this course, most of the time we're just prototyping things. We're not going to worry too much about that. If it really bugs you, you can have a try-catch statement and a loop to go back. Or it's not try-catch in Python, it's try-except. So if I do this int input, I should probably put a prompt here. Oh, actually, I can put a prompt here. I can put a prompt into the input. Enter an integer, like that. So when I call input, I can call it with a prompt. If I run this, it'll say enter an integer. I say 45. Failed because it's not less than 10. Of course, if I run that again, Control-Shift-E, and I enter something that's not an integer, I get this error. Again, we're not going to worry about it too much in this course, and we won't be doing too much input in this course, but you can do something like this. So you can have a try block, and then you can go except. You can put, it's throwing a value error here, so you can choose to catch just a value error here, or you can just say abort bad input, something like that. Okay, so now if I enter an integer, it's going to work, but if I enter a non-integer, it's going to say abort bad input. So there is a try-catch mechanism in in Python that you can use. I also want to point these things out. These are sometimes useful. Print allows you to print multiple things in a row. So I can go print 1, 2, 3 like that, and it will print them out. Notice they're separated by spaces. That's because there's a separator. And you'll notice when I start to type here, I get some help that I don't get when I'm in the shell. What it's showing me there is I can't mouse over it, but I can mouse below it. There are these what are called keyword parameters, named parameters, that have default values attached to them. So there's a parameter called sep for separator that by default is a space, an end which by default is a /n, and a couple of others. I can override those by putting them at the end. I can say separator equals, I don't know, star, and then it will print them out with stars between them. If I want to print on 2 separate lines, let me copy this, put it in here, sep equals that. I can also say, end equals, end by default is the carriage return, /n. If I go */n, then when I run this, I have to go through the whole rigmarole here. Whoops, there we go. It puts the end parameter onto the end. So what do we normally use that for, though? Normally we use that like this, because we want the next print statement to go on the same line as the original one. So if I say I want nothing on the end, I want the empty string on the end, then when it prints out the first line, it stays there, and then the second line goes here. So it's kind of like the difference between print and print line in Java. Print line is the default, and if you put end equals quotation marks at the end, I don't need the separator, by the way. I can do it without that. It will just default back to the space, and I can just specify that I want the end to be nothing. Okay, so that's printing. Okay, control flow. I'm not going to go through these. I showed you the if. There is an elif if you want an else if chain. That's an optional thing. So elif and then a Boolean expression and then semicolon and then colon. When you're writing Boolean expressions, remember that if you need logical operators, it's and or not. It's not ampersand, ampersand, bar, bar, exclamation mark. Other than that, they work exactly the way they do in other languages. You have a while loop, and that's really your only generic repetition. There is a for loop but it's very special. It's actually a for each loop. It's for iterating over objects that can be that have an iterative structure. So it's for iterating over strings or over lists. You can use it though as a typical counted loop. Whoops, you can do this. So if I want to count, let's put it down here, for I in range 10, print I. What that's going to do is, by default, range has a number of parameters. Okay, it's not going to give me the help here that I want. But there are a number of parameters. It has to have at least one parameter in it. If you just put 10, it's going to range from 0 to 9. So I is going to take all of those values in order. There we go, 0 to 9. If I wanted it to go from 1 to 10, I would have to tell it to start at 1 and end up to but not including 11. And now I get 1 to 10, like that. If I want it to count by 2s, I can put a step in here, like that. Now it's counting by 2s, 1, 3, 5, 7, 9. And there's another little trick I can do. I can tell it I want it to do the range reversed. So I put the range in here, and then I say reversed, and it's going to go backwards. The range is going to go backwards, 9, 7, 5, 3, 1. Okay, so the range is defined as 1 through 11, not including 11, counting by 2s. So 1, 3, 5, 7, 9, that's the range. And then when I reverse that, I get 9, 7, 5, 3, 1. All right. And we can also define functions. So let's do that real quick. Let's define a function. The keyword for that is def. I'm going to say define my function foo with 3 parameters, a, b, c. And then I'm just going to return a plus b plus c, like that. So when I run this now, it defines a function for me. Notice I didn't call it, but it's in my workspace now. Having run this, I've got the function in my workspace. I can go ahead and call it if I want. That's not going to work. It needs 3 arguments. So that's going to return 6, which is an integer. I can also give it strings. So because it's untyped variables, that will concatenate 3 strings together, since plus is also concatenation. But this, of course, will break it, because I can't do string plus integer without a conversion. If you want to add an integer to a string like that, you have to convert it explicitly with str like that. That's the way to do it. That gives you FDSA6. So when you're building a string with variables on it, that's how you do it. Okay, couple of other things. Now here we're going to get into some stuff that you may not already know. Let's do this. Let's do another function, foo with 3 parameters, and I'm going to return a plus b plus c and also a times b times c. So Python has this little trick where it lets you return 2 numbers. It's super handy, and we're actually going to use it in some of the example code that I give you, and I encourage you to use it in your code as well. Oops, I should have made this, let's call this double return. Notice how I defined 2 functions called foo there, and it didn't hiccup at all. Originally it was like this. That's because you can always redefine any name you want. So first I defined it to be that, and then I redefined it to be this, and that's okay in Python. So watch out for that. Let's just call it dr for double return, just to save some keystrokes. So now I should have, when this is over, I should have both dr and foo. So I'm going to go dr 1, 2, 3. No, that's not a good one because it'll be the same 4, 5, 6. Returns, this is what's called a tuple. Okay, so this is a tuple. And you can define tuples like this. So you could, if I say x equals 2, 3, 4, x is now a tuple. It says class tuple. A tuple is like a list or an array, but it's immutable. Once it's created, you can't change it. Okay, so it's a special kind of list. I can access the items separately, x0, x1, whoops, x1, and x2, but I can't change them. So I can't say, oh, by the way, up arrow and down arrow let you cycle through previous commands in the shell. Really handy. If I say x2 equals 9, not allowed. Okay, so when you define a tuple, I originally defined it this way. You might notice that they have brackets around them when you originally see them. Round brackets defines a tuple, but in certain situations you can define a tuple without using the round brackets. So what's happening here is we are actually returning a tuple. So let's do that again, the dr command. dr456 returns 2 numbers, but what's really nice is I can create a tuple of variables. So I can say, first one was add, the second one was multiply. I can say add comma mul equals dr456. So I've created a tuple here of variables that didn't exist before, and it's going to assign the first item that was returned to add and the second item that was returned to mul. So you don't actually have to worry. I'm telling you about tuples so you know what's going on beneath the surface. You don't actually have to know that. You can treat it just like, guess what? This function returns 2 variables, and I can use a list of variables here to assign to them. You can also do that like this: x, y, z, zz equals 1, 2, 3, high, like that. So it's a tuple of variables on the left and a tuple on the right. X gets 1, y gets 2, z gets 3, and zz gets the string high. Nice little feature of the language. Watch out though, if you accidentally put one variable like this, that works as well. Whoops. And what you get is the entire tuple gets assigned to the variable x. Okay, how are we doing? I think there's just one more thing, and again, this is something that you may not have seen before, which is you can define functions with default values for B and C. So these, we're using default values, and we can also use named or keyword arguments as well. So let's start with just keyword arguments. So I've got this dr function over here. By the way, I think, can I do this? Yeah. You can type the word help on anything you want. So if you go help tuple, like that, it's going to give you all the system help on the word tuple. There's also a nice, if you like it, there's a nice little interface here called interactive help. So I can type tuple here, and it gives me that. Sometimes I like to put this beside the workspace so that I can use both and I don't clutter things up here. So dr, once I've run the module, it knows what dr is. It knows it's a function, and this is its signature. So when I start to type dr here, it's telling me the variable names. And this is, you can do this in, I believe you can do it in in PHP as well. But I can say 1 for A, and then I can say C equals 3 and B equals 6. And it will pass in those 3. So when I can start doing positional parameters, so if I type them, if I just go dr, where is it, 4, 5, 6 like that, A, B, C get 4, 5, 6. It's done by position. But or I can starting from the right, I can start replacing the parameters with these assignment statements, and that means I want you, from this point on, I'm going to use named parameters, and I want you to use B for that and C for that. I can't do this though. That's an error. I can't go back to positional parameters over here. So this is a really handy thing, especially when it's combined with that's a keyword maybe? Oh no, that's fine. I can say A, okay, so A and B equals 1 and C equals 1, like that. And then return A plus B plus C. Maybe I'll do a print before then. Like that, just so we can see what we're getting. So I'm going to run that. Oops. Okay. So defaults is now a function. I can't call it with nothing. I need to at least assign an A. So I need to put a number for A, but the B and the C get the defaults that I've defined up here. This is definitely like PHP as well, if you've seen that in PHP. And I can also use the named parameters from this point on too. So I can say, okay, I want A to be 3, but I want to override the default for C and make it 10. So now I get 3110. That's really, really handy because you can define a really complicated function with 15 parameters and give most of them defaults, and then the user can just call it with 1 or 2 parameters that they need to set, and if they want to, they can dig deeper and override the default parameters as they go. So we'll be using this a lot in the stuff that we do. Okay, so that was kind of a whirlwind tour of Python. Like I said, some of it's review, some of it is probably some new stuff that you haven't seen before. Over in the exercises here, I would like you to try one of them just to get your feet wet. What I'm suggesting is that you try number 1 here. Write a function that chooses a random number from 1 to 10, then asks the user to guess it. Don't let them enter a number out of range. Loop back and ask again if they do. Once they enter a legal number, it should tell them whether they got it right or wrong. Oh yes, for random, this is how you do randoms. You need to do an import at the top of the program to import the random module. The random module comes with a bunch of functions in it which are accessed through dot. So random.randint 110 will get you a number from 1 to 10. So then it's just the guessing game. You've seen this before, but it's just a little get your feet wet. So this is for catching errors. This is for an ongoing dialogue with the user. Yeah, and you can try some of the other ones if you want. Some of that stuff, I guess some of that stuff that I just showed you about double return values and default parameters here, that stuff we'll be using more in later sessions. So, but you can practice that stuff as well if you want. Could be useful. It also says, note, by the way, in exercises, I think it says to write a function. So what you can do is you can create a program that just contains that function. Let me do a new program. Save as. I'm going to have to go through this rigmarole every time I save a new one. Okay. Just call a function. Just go def x 1, 2, 3. Return 1 plus 2 plus 3. Okay, so when I run the, should be A, B, C. These would need to be variable names. Okay, that worked. So that's what I'm asking you to do, is write a function like that, and then it's up to you. You can, after it's defined, you could call it right here, or once the function is defined and you've run the module, you can just call it here. I don't know why I wrote 1 plus 2 plus 3 here. That makes no sense. That's what it should really be. Okay, so you can just write a single function here, run the shell, run it in a new shell, Control-Shift-E, and then access the function over here. So that's what I'm asking you to do there. So just some real basic stuff. Get to know get used to Python again, and we'll come back in the next video with some data structures, some of which I think you may not have seen before in Python. Okay, see you in the next video.